Hi everyone, I am Nicolas Velasquez, and today we're going to talk about power smart grids and DC converters. Let's begin with a little introduction. This is our principal topic. Almost 80% of total energy consumption is consumed in cities, which is responsible for 80% greenhouse gas emission. There's a lot of contamination here. And we have a need, the distribution of electrical energy. We made that with a power grid, which is a traditional and centrally controlled system for the distribution of electrical energy. And we have here a need, a problem, and we have a solution. We have an opportunity. So there is a lack of monitoring and real-time control in the traditional non-smart system, which creates a challenging opportunity for smart grids to act as a real-time solution. So, finished the introduction. Sorry, we have the content. First, we're gonna talk about the concept and design. Next, reliability and security. Next, big data. And finally, DC converters. Okay, let's begin with the concept and design. We have here a schematic, a basic schematic. In the left, we can see the centralized power generation and renewable sources and microgrid. In the center, a smart grid. And in the right side, the distribution of the electrical energy to houses, to cities, and to factories. And we have here a two-way communication. You can see it. Okay, let's see the concept. A smart grid is a concept for the conventional grids with some latest and automated features which make them more reliable and sustainable. And we have here a table with difference between a smart grid and a conventional grid. And do you remember the last figure? Let's let's see this. Two-way real-time communication in the smart grid and one-way communication in the conventional grid. So we can analyze what's happening in two ways. So we have a large number of sensors are involved in the smart grid, and in the conventional grid, a small quantity of basic sensors are used. Another important difference between these kinds of grid is the security and privacy concerns in a smart grid, and no security or privacy concern in the conventional grid. The reliability and security. We have this basic schematic of a smart grid. A smart grid needs sensor, needs power systems, needs information technology, and it have to bring security, electrical storage, communication, reliability, integration microgrids, and between others. So a smart grid has a potential to detect any fault and allow the self-healing of all the system. This is basically control of errors automatically. For this, smart grids have capability to monitor and store all the data and estimate its service reliability. And in the field of security, with the increase of automation, remote monitoring, and controlling of the grid, it can make the grid more vulnerable by cyber assault. And in this uh, in this part, uh, we have some of researching about security and smart grid. Uh, Basically, this. And finally, with the smart grid, we have the big data. Big data is important. Smart grid is full dependent upon the data it receives. This is because the smart grid to has sorry the smart grid has to make decision um, with basically the information that it has. So in the left of this schematic, we have the grid measurements. In the center, the analytics of this data. Uh, and in the right, the data visualization. So uh, we can talk about DC converters. This is a huge important part of smart grid. Why? Its application, we can see this application in photovoltaic arrays, in fuel cell stacks, in battery systems, and electric vehicles in a normal smart grid. So, satellite application is valid too. So, what is a DC-DC converter? A DC-DC converter is basically an electrical component that converts a DC signal with a specific level to another DC signal to another specific level. Uh, this is why its name DC-DC converter. And we have different kinds of DC-DC converters. We have buck converter, boost converter, buck boost converter, and cook converter. And this is basically a review about smart grids, power smart grids, and DC-DC converters. My name is Nicolas Velasquez, and thank you.